All right, so if we look at the metric staircase, this is, again, a way of converting between units in the metric system. So if we have a kilometer, we can use something called the metric staircase to find out how many meters, that would be the base unit here, or how many centimeters that is, or how many decameters that is. And I do want to just make this note here, that should be dA. Okay, we'll use that as dA. And where's the other one? Micron, yeah, just micro is the prefix, that's all we need. So we can make that little change. But let me show you how this works, okay? Now, before we get to the examples, let me tell you about the instructions on how to use this, okay? Okay, when we have a unit given, like for example, let's use this one, 2.07 centimeters is, and the question would be how many millimeters this would be. So, how you do this is you locate the original unit on the step, on the staircase. And so the centimeter is actually here, right? So we're on this step right here. What you want to do then is locate where the prefix is of the one you're going to, you're converting to. And we see that it's right here, right? The millimeter. And here's this step. So you find out where you are, where you're going to. And this is so easy, it's amazing, it's awesome, okay? So what you do is you say, I'm starting here, and I need to go here. Now, what you're doing is you're going down the staircase to a unit that's smaller, but more importantly, you're moving to the right. And how many steps are you actually moving here? One. So, one step to the right means that I move the decimal one place to the right. And there's my new spot, and so here we go. It's 20.7 millimeters. Okay? 20.7. And that's how easy it is. That's how you use the metric staircase. Okay? So let's do another example. Okay? Let's pick something totally different here. Let's do 14.35. Let's say hectometers equals how many? And what's this? Decimeters. Yes, not deca, but deci. Okay? So deci. So we're starting here, and I have to go 1, 2, hit the base unit every stair, 3 to get to deci. You see that? So that's 3 spaces to the right. So where's my decimal and my original number? Right here. I go 1, 2, and when you skip an open space, you add a 0, and here's your new decimal space, 1, 4, 3, 5, 0. That's how many decimeters it is. No. Thank you for asking that. You do not just put a 0.0 at the end. And why do we do that? Why do we not do that? Because of what we talked about the other day with sig figs and precision. You don't want to add precision to this. Here we only have 1, 2, 3, 4 sig. We have 5 sig figs here, and no, sorry, we only. Oh yeah, no, this is a decimal, so we have 5 here. Here, by doing this, we have how many though? 1, 2, 3, 4, 5, 6. So if we were keeping sig figs, which in this, I'm not going to worry about the sig figs, because you would have to write this in scientific notation to keep the sig figs. So I don't want to burden you with that, so don't worry about that. Okay? So no, we just don't put a decimal 0 for no reason. We'll just move the decimal place, and that's it. Okay? So yes, sig figs don't line up here, but don't worry about that. It just happened for this example. Okay, another one. Let's see. Let's erase this stuff here. And I'll just get rid of this to make some room for myself. Let's say we have 351 micrometers. Oh, I just love writing that. Equals how many millimeters? Well, we start on the staircase. We start here. And we have to go up to millimeters. So 1, 2, and 3. So you're moving 3 spaces. So where's the decimal place in this number? After the, where is it right now? Right here, after the 1. So I need to move 3 to the left. That goes 1, 2, 3. So You can put a 0 here because it's not adding any significant figures, and this is, you can add a 0 there just to make that a placeholder. 3.351. Okay, so that 0 you can add. You can't add a 0 after the decimal place. We won't do that. Got it? Okay, so that makes sense. 351 micrometers are super small, and that actually only translates to 0.3 millimeters. Okay. Any other questions? Yes? The dots here, they're just saying that there's nothing there. There's no unit for that staircase itself. Yeah, there's no unit label. Remember, this is 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. The next one on the chart is this one, 10 to the negative 6, right? So there is no 10 to the negative 4 unit or 5 unit. Okay, so the rest of the instructions, as we've already done, we've mentioned, count the number of steps from original to new unit, move the original decimal point in that same direction and by the same number of steps. Okay, and then you change your prefix or symbol to the new unit. So that's just like what we've done. All right, one of the other things that you're going to need to do is to convert not just straight lengths, but you're going to need to convert areas and volumes as well. And that's a little bit different when we're using the staircase. Just one more thing you got to remember. So what I'm saying is this: 14 centimeters equals how many meters? That is a straight length conversion. And if we go back to our table, what we see is centimeters to meters, we move 2 spaces to the left. And so this is going to be 0.14. Agreed? Okay. Now, what if I had something like this? 14 centimeters squared equals how many meters squared? The first example was a length, right? The second example is an actual area. And I'll make that square because it's squared. Okay? Now, if you think about this, it's not the same as just moving 2 decimal places. Why? Because each meter is 100 centimeters. So if you do 1 meter times 1 meter, that's 1 meter squared. If you do the same area, but you change it to centimeters, okay, that's 100 times 100, that gives you 10,000 centimeters squared. So do you see how we're not just talking about 2 decimal places anymore? How many decimal places are we talking about? 4. So it's different. It's not just the straight length. So when you're talking about area, what you have to consider is, or any of these calculations, you have to consider the exponent that we're going to, okay, or the exponent that's involved. And so because I'm multiplying this number by this number, then that compounds the number of decimal places that we have to move. All right? And so the process is pretty simple. It goes like this. You do everything the same. So let's just write some notes here. Okay? When converting from squared units to squared units, for example, we're doing in this example, the process is the same as converting length. So the power of 1, like centimeters to meters. It's exact same, except that you multiply the number of decimal places that you would normally move by the exponent involved. So if we go back to this right here, meters to centimeters, okay, if you've got 1 meter, that would normally be 100 centimeters, right? That's 2 decimal places, according to the staircase. But when we've got meters squared to centimeters squared, you see that? We're actually going 4 decimal places, which is 2 times the exponent, 2. That's 4 places, see that? So if we go back over here to this example, centimeters to meter would normally be 2 decimal places to the left. But because they're squared units, how many decimal places to the left should I go? 2 times 2, 4. Very good. So watch this. This has got to go 1, 2, 3, 4. Fill those with zeros. Put your decimal there. Here's your answer. 0.0014. Okay? It's different than just converting the length. Let's do an example here. You can do an example here, and then we'll see if you know what you're doing. Did you get all those notes there? Okay. So let's say we have 3.7 meters squared, and I want to know how many decimeters squared that is. Okay, so just take a moment and do that, and let me see your answer. Did you get it right? Meters to decimeters, you would normally go one space to the right, but because it's squared, you would move two spaces to the right. And of course, that looks like this. This decimal would go 1 and 2. Put a 0 there. 370. Okay? Any questions about that? Okay. All right. So one more thing. When we're doing cubic units now, the process is now the exact same, except instead of multiplying by 2, we multiply by 3. Okay. Let's do centimeters cubed. Sorry, cubed. Let's do 3. 33.3 centimeters cubed equals how many millimeters cubed? So we're talking about, right, a volume now, three-dimensional. If this is 33.3 centimeters cubed, what is that same volume in millimeters cubed? So go ahead and do that. All right, let's see how you did. There it is. Did you get that number? So with cubic, you times 3. Centimeters to millimeters is one space to the right on the staircase, times 3. Make sense? Any final questions about that? I'll give you your sheet to work on, and if you have any other questions, you can ask in a bit. Okay? So that's converting using your metric staircase, also with squared and cubed units as well.